Hello, my name is Stacy Wright, and I would like to welcome you to the Designing for Wildfires training series presented by the Federal Emergency Management Agency's Building Science Disaster Support Program. This is Module 4 by the Marshall Fire Mitigation Assessment Team, or MAT, focusing on building level considerations. In this training series, the MAT hopes to expand knowledge of wildfire vulnerabilities in the built environment at different scales, from the community and neighborhood level to the subdivision and individual lot scales, and discuss resources and best practices. This training is Module 4 in a series that includes 5 modules. I will hand it off to Darlene Reaney to lead you through this module.
So as we've learned in Module 2, there are two main categories of fire safety provisions at the building parcel level that help to limit the ignition of structures or buildings to wildfire hazards. For this module, we'll be focusing on structural hardening measures, which is a range of building construction features that can be implemented into the design of a new building or introduced as retrofits to existing buildings or homes to help limit structure ignition and total loss due to wildfires. And these measures include various active and passive building features, elements, and systems, generally from the top of the structure down to the foundation. And some examples of that are roof covering classification, joint detailing, etc. And all of these will help, again, limit ignition and fire spread. Module 5 will go over aspects of defensible space, which is the immediate space surrounding a home or structure, also to help slow or stop a wildfire from reaching a home or building, and also helps to reduce the likelihood of structure ignition.
So residential roofing systems are a key area of known wildfire vulnerability. Many homes burn from the top down during fire hazard events. There are several mitigation strategies that can be taken to help protect roofing systems. This includes installing a Class A roof per ASTM E108 or UL 790. This could include asphalt shingles, concrete, brick, etc. The entire roofing assembly should be Class A, not just the roof covering. Wood and fiberglass for new or replacement roofing systems should be avoided, and the number of joints and elevation changes in the roof design should be limited. Proper flashing should be used at the joints between walls and porches, porch roofs, lower roofs, and roof edges. Roof valleys can create areas for debris and embers to collect. This could lead to ignition of the roof at the joint if it's not Class A, or if the valley is combustible, or the adjacent non-fire rating cladding on the adjacent wall or dormer could ignite. Additionally, interfaces between the roof and wall systems can leave parts of the home vulnerable to ember intrusion if gaps are present. There are a few ways that these areas can be protected from these vulnerabilities. One way is to provide non-combustible valley flashing with an underlying mineral surface cap sheet or interweaving the roof. You may also provide non-combustible flashing and counter flashing 6 inches off the roof at the wall-to-roof interface, or the bottom cladding can be replaced with non-combustible siding. Edge of roof systems present areas where easily ignited debris can accumulate, as well as, if left unprotected, can lead to ember accumulation and/or intrusion during fire hazard events. Mitigation strategies to help reduce these vulnerabilities include using metal gutters and downspouts, installing corrosion-resistant non-combustible drip edge flashing from the roof to the gutter, using tightly fitting flashing against the gutter, or providing non-combustible gutter covers. Using enclosed soffits or appropriate vent screens and bats in soffits further helps protect these areas. You may also provide bird stops or mortar at open ends of tiles on profile tiled roof edges. And for other types of roof edges, you can provide an underlayment that is continuous to the roof edge and metal flashing with a return and cap sheet. All edges, joints, and pockets created in roof design create locations for ember and debris accumulation. There are some actions that can be taken to protect vulnerable joints. This includes installing non-combustible metal flashing and counter flashing to protect the roof to combustible chimney chase joint for at least 6 vertical inches above the roof surface. You may also replace this area with non-combustible cladding. For other roof penetrations, you can make sure the joint is well sealed to minimize the entry of embers, and roof penetration should be sealed per the manufacturer's instructions if not available. This should be sealed with fire-resistant caulk, non-combustible mortar, compressed mineral wool, fire rate expanding foam, or metal flashing.
Another key vulnerability in the exterior envelope of a home or building is the roof attic space, particularly when openings into the roof attic space are unprotected. So this would include any type of roof vent that is open to the attics that can be located anywhere along the roof, such as the ridge line, mid-roof, roof eave soffits, gabled walls, or dormers. And so during a wildfire, especially during high wind events, embers can readily penetrate the roof envelope and into the attic space via these unprotected vent openings. And in addition, overpressures on the windward side of the roof, coupled with underpressures on the leeward side, can create this suctioning effect that draws embers into an attic space via both inlet and outlet openings. So this is a major concern and source of ignition, as attic spaces are typically constructed of combustible materials with a lot of exposed wood surfaces, as well as storage of combustible goods, furniture and storage boxes, along with having a lot of collection of dust and debris, all of which are readily ignitable. In addition, attic spaces are typically not provided with fire detection or suppression systems such as sprinklers. And so if a fire were to start in the attic space, it will likely go unnoticed and ultimately lead to total loss of the building. So on this slide, we're going to show you a video from the Insurance Institute for Business and Home Safety, also known as IBHS. And this video shows a compilation of fire tests of various vent openings and associated protection measures. So as we see in the video, there's going to be a series of different types of vents that could be found in either the soffit area of an attic space or along a gabled wall. This one here is showing a soffited eave with a vinyl strip vent. And as you can see, there's some embers that are coming through along the interface of the roof line and the soffit. So as these videos progress, there will be other types of vent details and varying degrees of ember intrusion. So here we have a soffited eave again, but this time a fiber cement vent. And as you notice, there's little to no embers that are currently entering the attic space via that type of vent. Here's a different type of setup where we have, again, a soffited eave strip vent. In this case, the vent is located closer to the wall. This is an example now of a gable end vent where you can see that embers are readily entering the attic space. And then here we have just an open eave vent in blocking with kind of the standard 1/4 inch mesh. And as you can readily see, a significant amount of embers are entering into the attic space, given this sort of very basic mesh covering. We now have an open eave with a fringe block vent, again with a 1/4 inch mesh. There are, in this case, less embers that are entering, but still embers are readily entering into the attic space where there could potentially be other combustibles that could readily ignite. And here we have, again, another open eave vent in blocking, this time with 1/8 of an inch mesh. As you can see here, there are still actually embers entering, although a lot less than the 1/4 inch mesh. But this is a key finding that we introduced into the Marshall Fire mat products, where the recommendation was to go to 1/16 of an inch mesh. So hopefully the previous video illustrates the importance of appropriate vent protection. This diagram here is just an example of a ridge vent with proper screening. In this case, it shows 1/8 of an inch, but the recommendation from FEMA and from the Marshall Fire is to reduce that mesh to 1/16 of an inch. So there's various mitigation strategies for vents. Some include, covering all plumbing stacks, attic, crawl space, soffit, and ridge vents with non-combustible, corrosion-resistant metal wire mesh, having openings no larger than the 1/16 of an inch for both new and or retrofit construction. Replacing any existing non-fire rated louvered wall vents, such as those for clothes dryers with fire-rated, non-combustible, or fire-resistant wall louver vents. Just to be sure, after upgrading the louvers, that they open and close properly. And also as a reminder, to not use mesh and louver dryer vents. In the event that you're replacing or reinstalling vents, making sure that you use a fire-resistant caulk to seal around the edges of the vent is helpful to not only prevent water, but also ember intrusion between the vent and the exterior wall interface. Another critical area of the exterior building envelope are the wall assemblies. For the wall cladding itself, non-combustible materials such as fiber cement board, masonry veneer, or stucco should be used, and where possible for existing construction, providing 1 or 2 layers of 5/8 type X chipboard on the backside of the cladding and wrap. This provides increased fire resistance to help not only limit potential structure ignition, but also help to slow down fire growth and spread in the event ignition does occur. For new construction in high fire prone areas, particularly for homes or structures that are closely spaced within 30 feet of another structure, 1 hour fire resistance rated exterior wall assemblies are recommended. One area to also focus attention is at the bottom of wall to foundation interface. During the Marshall Fire and in other major wildfires, the bottom of wall detailing was another key point of vulnerability that was observed to lead to structure ignition. At the bottom edge of exterior cladding and interface with the foundation, in some cases, the continuity of exterior cladding was not maintained at the return edge of the cladding. This left exposed combustible materials, as well as avenues for embers to potentially enter the wall cavity and lead to a concealed fire within the combustible wall space. So this slide here is just showing a more detailed example of this bottom of wall detail and that return edge. And as you can see, there is some exposed combustible OSB sheathing, which again could be a potential site for ignition of this exterior wall. The image on the right shows an example of both a non-combustible cement board cladding system in combination with a non-combustible ember resistant zone 0, which is the 0 to 5 feet from the bottom of the wall away from the building. These two design features in combination provide increased resiliency to the building along these details. Final note, for insulation, it's recommended that ignition-resistant fiberglass, batt insulation, or other non-combustible insulation is used to further limit potential exterior wall ignitions. So on this slide, Julia, if you want to already play the video, we wanted to show a side-by-side set of fire tests of 2 different types of common wall assemblies that include vinyl siding. The one on the left has wood furring strips, a water-resistant barrier, mineral wool insulation, and asphalt paper. The one on the right is just vinyl siding with asphalt paper. And as the test continues, you'll see that while the tests on the left might perform slightly better with respect to rate of spread, both vinyl wall systems perform poorly. So as you can see, both walls are performing poorly from the beginning, but as the fire is progressing, both sort of assemblies perform quite poorly. Eventually, if you want to fast forward to the end of the video, you'll get full ignition of the wall assembly on the right, but the wall assembly on the left is also performed poorly and likely would have led to ignition of the entire building. If you want to go ahead, Julia, play that video. So in this video, we wanted to show that a wall assembly with fiber cement cladding, which is a known non-combustible cladding material, and also is known to be fire resistant, However, in this case, the overall wall assembly actually performs poorly in fire conditions because the interstitial space of the wall cavity is filled with combustible insulation. So as this test continues, you'll see that the wall will become engulfed. And this is just a reminder that even if you have fire-resistant cladding, that alone is not enough. And we need to be mindful of providing non-combustible insulation materials to get overall performance that we are anticipating. And also, this probably comes up a little bit more. We're concerned about both meeting fire resistance and energy efficiency goals. And so in those cases, just to be reminded that meeting energy efficiency goals, we also need to be mindful of not exacerbating any kind of vulnerability or risk for fire resistance. So providing non-combustible insulation is prudent.
So many joints and interfaces throughout the exterior of home are vulnerable to ember intrusion. These include roof-to-roof joints, head-of-wall joints, bottom-of-wall to foundation interfaces, wall-to-wall joints, window and door joints or doggy doors, and also garage doors. And you can see on the right here that we have many picture examples of areas where you could have ember intrusion in these types of assemblies. Glazing systems can break due to radiant heat from debris, which can allow embers to enter the home. There are several actions that can be taken to reduce the likelihood of this happening during a fire hazard event. You can use tempered glass and double pane glazing systems for windows and doors with glazing. Aluminum coverings can be installed, or you can use metal framing for window and door frames, and you can use metal screening on windows. And to the right here, you see a range of window damage due to fire exposure from proximate buildings, vegetation and fences between 5 and 40 feet away. This also comes from IBHS. Attachments such as decks, patios, porches, and balconies can act as wicks that once ignited from embers or direct flame contact can provide a direct vehicle to igniting the home. There are multiple ways that you can protect these types of structures. Using non-combustible materials for deck framing, walking surfaces, railings, stairs, etc. is highly recommended, and all metal components should be corrosion resistant. You can also space deck boards with a 1/4 inch minimum gap. Alternatively, you can use non-combustible solid walking surfaces such as lightweight concrete. You can also enclose the space under the deck. This would be 4 feet or under from the ground, with corrosion-resistant metal mesh having openings an 1/8 inch or less. Alternatively, you can fully enclose the underside of the deck with non-combustible materials. If the ground below the deck slopes more than 10%, the enclosure should stop within 6 inches above the ground surface to allow for drainage. You can also provide non-combustible flashing between or on top of the deck surface and the adjacent exterior wall. The flashing should be extended to at least 18 inches up the wall, and it should be tucked in behind the lap joint. And we have 2 details here showing the ideal installation of an assembly like this.
So that's the end of our module for materials. As a final reminder, the Marshall Fire MAT produced a MAT report with 7 additional fact sheet documents as shown on this slide. In addition, this slide contains a link and QR code to FEMA's disaster support page. Additionally, the files can be found using another internet search engine by typing FEMA Marshall Fire MAT products.
That wraps up Module 4 of the Designing for Wildfires training series presented by the Marshall Fire MAT. Next in the series is Module 5, focusing on defensible space. On behalf of FEMA's Building Science Disaster Support Program, thank you for taking time to review this module.